Question 12 says, in an experiment to determine the refractive index of glass, a student directed a ray of light towards a glass prism. The ray of light is shown before and after entering the prism. Determine the refractive index of glass. Guys, as you can see, the angles that is given in the question are not with respect to the normal. So the very first thing you have to do is draw a normal and then mark the angles with respect to the normal, of course. So this is my angle of incidence and this is my angle of refraction. And once you have these two angles, use n1 sine theta 1 equals n2 sine theta 2. So n1 is of air and the refractive index of air is 1, and the angle in air is 58 degree. And n2, this is what you have to find out, times sine theta 2. Sine theta 2 is the angle in glass. So if you make n2 the subject of the equation, the value is 1.32. Next question says, draw on the diagram the ray of light as it emerges from the prism at A, and no further calculations are required as it emerges. Guys, so when light emerges out of the glass, it is traveling from a more dense to a less dense medium, and when light travels from a more dense to a less dense medium, it bends away from the normal. Next question says, a different prism is made of glass with a refractive index of 1.63. Calculate the speed of light in air. Guys, refractive index is one of those quantities that can be found out using multiple equations. So ratio of sin I and sin R gives refractive index. Ratio of speeds also gives refractive index. So the speed in air divided by speed in glass also gives refractive index. So speed in air is 3 times 10 to the power 8 divided by n is 1.63. That gives the speed in glass. And as you can see, the speed in glass is a little bit lower than the speed in air, because when light travels from a less dense to a more dense medium, its speed decreases along with its wavelength. But we already saw in section A that the frequency remains constant.